To find the equation of hyperbola centered at 0, 0, you need to be able to find its a and b values. So for a horizontal hyperbola, we have this general equation here, with vertices at plus minus a comma 0, slant asymptotes at plus minus b over a times x, and foci at plus minus c comma 0, with the equation to find c if you have a and b of c squared equals a squared plus b squared. For a vertical hyperbola, it's similar to the original one. You can see both at the same time, except the x's and y's have switched. Vertices this time is at 0 comma plus minus a, slant asymptotes at plus minus a over b times x, and the foci are at 0 comma plus minus c, with the same c squared equation to get that if you know a and b. So we're going to do a couple examples to find an equation of each one. So again, these are all centered at the origin, and we have specific conditions that we're going to be given to find it. So for the first one, we have foci at plus minus 5 comma 0 and vertices at plus minus 3 comma 0. Since the x values have numbers, we are going to be using the horizontal hyperbola equation here. That's going to be our general form. So x squared over a squared minus y squared over b squared equals 1 is our general form. From our foci and our vertices, we can see that c equals 5 and that a equals 3. Now I know a, the nice easy one, but I still have to find b. So to find b, I'm going to use my c squared equation. So c squared equals a squared plus b squared. And so plug in my a and c, and I'm going to get 25 equals 9 plus b squared. Subtract the 9 over, I'm going to get 16 equals b squared, and then square root both sides, and I'm going to end up getting plus minus 4, but I don't really care about the negative, so I'm just going to keep the positive for this question. So I now know a, I now know b, and I know my general form of the equation, so I can plug in my a and b to get the final form. So x squared over a squared, which is 3, so we're going to get 9, minus y squared over b squared, which is 4, so it's going to give me 16, equals 1. And there is my general equation, or my equation for the hyperbola given this information. Next, I'm giving foci of 0 comma plus minus 8 with asymptotes at y equals plus minus 1 over 2x. So this time, my y value has numbers instead of my x, which means I'm going to be using the vertical hyperbola equation to be able to find all the information I need. So, general form is going to be y squared over a squared minus x squared over b squared equals 1. Now from here I see that my foci, 0 comma plus minus 8, gives me a c value of 8. But I can't find a and b from just c, so I need to be able to find one or the other to be able to find the missing one. But I do know that my asymptotes, plus minus 1/2 x, are given to me, so it must mean they mean something. And I know the general form for an asymptote for this kind of hyperbola is plus minus a over b x. So I can do something with this. I can probably set them equal to each other, the 1/2 and the ab. So that's what I'm going to do. So I'm going to do 1 over 2 equals a over b. I don't have to worry about the x's or the y's. I need to know what's different between the two. And I can solve for a here. I can multiply the b over, and I can get 1 over 2b equals a. That's all well and good, but what can I do with it? Well, I know it takes a little bit of critical thinking to kind of see it, but we got c. Well, I still have my equation of c squared equals a squared plus b squared. Well, I can plug in c here, my 8 for c here, and I can get 64 equals a squared plus b squared. And I can actually solve for a here. I can subtract the b squared over and square root both sides, and I can get a by itself. So that's what I'm going to do. 64 minus b squared equals a squared. Square root both sides. Square root of 64 minus b squared equals a. Well, now I have these two equations right here, both set equal to a. So what I can do is set them both equal to each other and solve for b. So that's what I'm going to do. Square root of 64 minus b squared equals 1/2 b. And now I can solve. Square both sides so I can get rid of the square root. And I'm going to get 64 minus b squared equals 1/4 b squared. I can add the b squared over, combine like terms, so 64 equals, let's see here, 1/4 and 1 is going to give me 5/4 b squared. And then from here I can multiply the 4 over and divide by 5, and that's going to give me 256 over 5 equals b squared. And then I can square root both sides, and I'm going to end up with 16 over square root of 5 equals b. So I now know what b is. Now I can go back and figure out what a is. So I'm going to actually go back and do the original c squared equation here, where I have 64 in, and solve for a. So 64 equals a squared plus b squared, so that's going to go back to 256 over 5. And I'm going to subtract the 256 over 5 over to 64, and it's going to give me 64/5 equals a squared, and then I square root both sides, and I'm going to get a over square root of 5 equals a. So now blissfully I have a and b, so I can plug it into my general form for the hyperbola and get my final answer. So a being 8 over root 5 and b being 16 over root 5. I'll just go back up here, and I'm going to get y squared over a squared, so that's going to be 8 over square root of 5 squared minus x squared over b squared, which is 16 over root 5 squared equals 1. And you can rationalize the denominator and get the fractions out, but this is just how to set it up. And so this one took a while, but these are the steps you would have to go through to be able to get the equation of a hyperbola for this one.